You're listening to The Fire Break with Steve Wolf. Hey, welcome back to The Fire Break. I'm Steve Wolf. We're sponsored by Team Wildfire, developing new technologies for putting out fires. And today I've got a guest who's also working on some pretty cool new technology for putting out wildfires. I've got Torsten Gerwig, and Torsten is the CEO and the founder of DICOSI, which is, disaster. Tell me what it stands for, Torsten.
Yes, hi Steve. Thanks for having me here today. DICOSI is the short form for disaster control systems.
Disaster control systems, right?
Yes.
Right, and I guess people have a disaster because things are not under control.
Yes.
Right? So that's a pretty good start at a way to think about. So tell me about some of the technology that you're developing, the things that you're working on.
Yes.
And the type of disasters that you focus on.
Just to give you a short overview about the DICOSI. So I'm the CEO. I'm not the founder, to be honest. I'm the CEO. Just the CEO working together with the founder, which is also CEO. DICOSI starts with the Turbo Hydrojet system. So I guess you know the technology, working with turbines and working with water. And this was our start of the company. So we took over the technology, the Turbo Hydrojet technology, from another company, which said, okay, another company was splitted. They said, we don't want to work with firefighters anymore. We have another place now, another industry they are working for. And then we took over this technology, the Turbo Hydrojet technology, and made some new developments, made it smaller, made it as a box, made it flexible, etc., and modular. And this was the start of the DICOSI, which was founded then in Germany 2018. And we are also built up a production of all these. And now since 2018, we are working for the fire departments, for disaster control units, and also some special project for the German army, which we are doing. So we are not only producing now the Turbo Hydrojet systems, we increased our product portfolio for firefighters. And we built some roll-off containers for fire units. We are building special vehicles. We build transport vehicles. We are also building tracked vehicles for the disaster control units. And our special thing is the Turbo Hydrojet with the airplane turbines, which we are working.
And so it's basically taking tools from nature, right? Wind and rain.
Yes.
And then recreating them in an environment or in a way where you can direct the rain and the wind where you want it.
Yes. We can direct the rain and the wind, and we took over this technology. And this technology was done, or there was a research from the German Ministry of Education and Development, and they made some developments. So they were studying this technology, and with these results, they were looking for a supplier or for a producer who can produce this. And this was started then in 1996, and the former company made this first system together with BASF, the chemical company. And since then, this technology is in use in Germany for this chemical plant. And this was made, it was a huge truck, and it was built up with military jet engines. So they have a really high consumption of about 1,000 liter kerosene per hour, and really loud. And we took over this technology now and built up, let's say, a new system. We take now civil engines, which is not so loud anymore. Then we take our engines are running with diesel. They have a consumption of about 450 liters per hour, so it's easier to use them. They can set up on a truck, but you can also set it up on different other vehicles or roll-off containers, or you can put it on the floor. You just need to connect the water, and the system is running.
Very interesting.
This is now the new topic with with this technology.
So you're only consuming 450 liters per hour of diesel now.
Yes.
Do you run on straight diesel, or do you need to add a lubricant to that?
No, just diesel.
Just
We
diesel.
just need diesel. If it's don't depend if it's winter or summer, we just need diesel, and the system is running with diesel. And we have a diesel tank on board in this box with about 1,200 liters of diesel. So
Okay.
it's running about nearly 3 hours. And you can refill it during operation. So no need to stop the engine. Just refill it. And yeah.
Diesel's not that flammable. I mean,
No,
unless you're
no.
inside it, right?
Yes.
You could put out a match inside in a bucket of diesel. It's pretty stable. Yeah. And what type of consumption rate are you doing on the water?
On the water, so the maximum with a one jet engine, the maximum you can bring out is about 4,000 liters per minute.
Per minute, okay.
This is a lot of water, and we now made a lot of tests, and our customers in average are working with about 2,000 liters. So 2,000
Per
liters
minute.
per minute, yes, is
So that's
enough.
2 jets then?
With two jets, you can get 8,000 liters of waters.
Oh, okay. I thought you said a 1,000 per minute was the most you could get for each jet.
No, 4,000.
Oh, 4,000. Okay, got it.
Yes, 4,000 is the maximum.
1,000 gallons is what I was thinking. Okay. Silly
Yes.
me and my imperial measuring system.
Yes,
Yeah. Right.
It's a different
No,
measuring system. Yes, we are talking about liters. Yeah.
Right. Okay. So 4,000 liters. Okay.
4,000
and so
liters.
if you take the 4,000 liters of liquid and then you turn that into mist, then how much volume of mist are you creating?
There's I don't know exactly the volume, but it's let's say with one jet engine we create a mist with approximately 120 meters long, and it's wide about 40 meters.
Okay.
And yes, and we have a defined droplet size, which is per droplet size it's 400 micrometers. So this was the result.
Is that the same as a micron?
I guess 400 micrometers, single micron, yes.
400. Okay.
So it's not
What
a
is that?
really,
What is that about in millimeters?
it's smaller than millimeters. It's
2 millimeter.
400 micrometers is about. Just give me a second. So this was the result which we get, or which was studied by the ministry, that you have the biggest water surface, and it's not. It's a 0.4 millimeter.
0.4 millimeters diameter
Yes,
sphere.
droplet size. Yes.
I see. Okay.
So it's not. Then at the end, it's not a fog or a mist. It's really small rain droplets. So you see it. I also uploaded some videos. If you, I hope you got it. Then
Yes,
you can
I've
show
seen
it
them.
later. Where you see the droplets inside. It's raining down. It's not only a fog which is in the air. So you have a really like a rain cloud with really small droplet size, where you also bind the smoke or chemical stuff, which will bind by the droplets and will rain down.
So you're precipitating it, right, by using more
Yes.
surface area to draw it. And do you need to add like a wetting agent or something so that it can bind more easily to the things it contacts?
No, you don't need any agents. You can put agents in there. So we can also bring out foam or something with the percentage 1, 3, 6. This is with the maximum 6 liters or 6% foam, which we can bring out with also with the water mist. Or you can also add like this fire soap, gel. Which you can also bring out. So this is all possible. You can bring out everything, just should be no alcohol inside.
Yeah, right. And how do you control your micron size? Are you using like a misting head to create the particles and then accelerate them, or do you break them into the small particles using the speed of the jet?
So this is a bit the the topic, which was the result of the research of the ministry. So we don't bring. I saw your video. So you bring the water directly into the airstream. So we don't bring the water directly into the airstream. We set up the water on top of the airstream.
Above it, yeah.
Yes, and there we define with the angle and with the dimension where we put up the water on the airstream, and the definition of the airstream and the definition of the water. Then we have the result where to put up the water and how much water, etc. And then we create this droplet size.
I see. And so did you find that as you vary the thrust of the engine, you also have to vary the means of input on the water?
No.
In order to maintain?
No.
So it's the same across all spectrum of the thrust?
Yes.
Okay. And
Yes.
how much thrust do the engines make?
The engines, we have they have about 3,000 horsepower, and it's about 10 kilonewton thrust, which we have.
10
kilonewtons.
Oh, 10 kilonewtons of thrust.
Yes.
Okay.
So here we are using the jet engines from Cessna or something, from civil jet engines.
From civil jet engines. Okay.
Yes, which we are using.
And do you need to use new jet engines, or can you recycle?
No, we don't need new one, because new ones are too expensive.
Right.
So we have our own jet engineers, and they are traveling around the world and checking airplanes which get new jet engines, and then when the old engine is still on board of the airplane, then our engineer is coming and is doing the test. He's checking the engine, is checking the thrust, vibration, everything. And then at the end, when these figures are all good, then we say, okay, we will take the engine. And then the engine is coming to us, and then we are doing some industrialization. We are taking all the airplane sensors away and putting industrial sensors on top, and just to get this change of configuration that we also can use the diesel. Here we are doing internal work on the jet engine. Yeah.
So you have to change the fuel port size because of the different density of the fuel?
Yes.
I see. And then you stick it in there and burn it, and poof.
Yes.
And what type of customers are seeking your services right now? Is it, you said you started with BASF. Were they using this for managing chemical fires in the manufacturing plants?
Yes. So we started with a lot of with the chemical industry, because there the system was used to cool down some structures, to wash out the chemical material, etc., from a safe distance. This was the start of all this. But now the more users we have now, they say, okay, we have the Turbo Hydrojet in our chemical place, and when there is a fire outside of the chemical place and they can support, then they are taking our system and they are driving out and supporting the other firefighters. And so we saw there is a lot of other applications for this system. So, for instance, industrial hall, burning industrial hall, etc. You blow in the water and the airstream and water mist, and taking the air of the fire and extinguish the fire. Or for tunnels, for long tunnels, we made tests with tunnels about 9 kilometers, where we can blow out the fog, etc., or the fog out of everything out, and the heat. Also the heat. This is important in tunnels. We blow away from the disaster so that the firefighters can enter, and the heat is not too high. And then also for some wildfires in Switzerland, for instance, there is also one system from us. And when there was this wildfire, they went out and helped them to extinguish the wildfire. There is also one video I have sent to you, which is showing this. Yeah, this was in Switzerland last year. And so you see,
I thought nothing bad ever happens in Switzerland.
Sorry?
I thought nothing bad ever happens in Switzerland.
No, normally not.
Exactly. Right. So when you were talking about when they use this on wildfire, you're talking about for direct suppression
Yes,
versus
this
for
was.
dispersion of chemical barriers. That's one of the things that we thought might be used for the technology would be to lay out retardants in front of a fire rather than
Mhm.
just doing direct suppression attack on the fire.
Yes. So the our thoughts are the same. So you can use the system for doing a barrier for to save houses, to save industries, or to save yeah uh, um, infrastructure. That you make a barrier that the fire is not coming in this area. But you can also work directly into the fire, um, which we already tried. But yes, we have no we have no experience now at the moment with the system working against this fire directly. We just talked
Okay.
to a lot of guys, and they said, okay, it depends on the fire, but with our system, with this 120 meters length we can get, and we can get up to 80 meters height. So you can also blow directly into the fire.
I see.
Mhm.
Tell me about the use you said on structure fires where it wasn't really the intended use, right, at BASF, right? But if they had a structure fire, they could use the technology, the jet rain, the hurricane technology. Uh, are they using it on the outside of the structure to cool it and stop it from spreading to other structures, or are they actually trying to inject the airstream and the mist into the structure itself?
This depends a bit on the accident they have. So when they have a structure which they want to cool down to that the structure is not getting damaged and is breaking together, then they can blow directly into the structure. And with the jet engine and with the exhaust gas, you get this three-dimensional way where you can transport the water. So it depends. When there is a structure with which you want to cool, you can come from one side blowing into the structure, and you also cool it down from the back side because of this three-dimensional airflow you get.
Right.
And this is one part, so you can cool down the complete structure. You can at the same time you delete or you wash out the chemical, all the chemical things inside the air. The second thing is when you know you cannot stop the fire and you cannot save this infrastructure, it's not worth anymore. You need to, let's say, burn it down in a controlled way. Then you
Yeah.
can save the rest of the infrastructure on the left or on the right side, putting a barrier between the burning thing and the not burning thing. Because with this kind of system and with this way of using the water, there is no heat and no flammable parts going through the airstream with the water. Yeah.
Right. So you're using both convection and basically a rain curtain
Yes.
as a basically a giant insulation barrier that you
Yeah.
can blow into place for as long as you need it, and then you turn off the jet engines and the barrier's gone. So you don't have to go hang a big fire curtain between the two buildings or something, right? You're just
Yeah.
using
Yeah.
the rain curtain.
Mhm.
Very
Yes.
interesting. So when you started making the machines, you had ideas about, how the application would work. But it sounds like once you put the technology in the hands of the end users, they're telling you about new ways that they figured out how to use it.
Yeah,
So,
this is also interesting. Yeah, but as you know, when the system is in use, so there was one way how to use the system. There was the need they had to purchase the system, and when they have the system, the nice thing is that they always do the training with the system. So one time a month, one time in 2 weeks, it depends on the different fire departments they are training with. They do training with the system. And then they also try some other applications where you can need this kind of technology. And yeah, especially with the small droplet side and with the cooling function you have.
do they
So
ever call you for your input? Or do they say, "Hey, Torsten, we're thinking about using it for this. Is that safe?" Or do they just go and do it and then tell you what happened?
No, it depends. Sometimes they call us and say, okay, now we have this training and we try to do this. What do you think? And we say, yes, this is a good idea. Let's go for it. And then call us afterwards and give us some information. Or on the other side, we say, hey, this is a good idea. We come and we join it so that we also see how it's working. So this is also a part where we also join the training of these fire teams. Last year we have been in the Netherlands, in Rotterdam. There is a big training center where the firefighters go there and train. You can bring out water and foam and everything. You can train with the tank, with big tanks or with structures. You can burn it. You can make fire and everything. And there we have we have been the whole day and doing different scenarios with the system, with foam, without foam, and try how the fire will, what happens to the fire when we bring out the system. And there we also had a nice thing because, the most firefighters which see the system at the first time, they always think, oh, it's a special system, and they are a bit afraid of handling the system because it's a jet engine, etc. But there we had a nice picture. There have been around 15 to 18 firefighters which have been trained there, and only one person was working, and this was the guy with the remote control system for the Turbo Hydrojet, and the other 17 stood there with their iPhone and making some videos of the system, So this is a nice story because they see that you don't need to be afraid of using the system. It's easy. You just have one remote control station with a joystick and 4 buttons. One button is to lift up the engine. One button is to start the engine. One button is to stop the engine. And the other button is to bring down the engine back in the box. And that's all you need,
And so can you also, while you're using it, vary the amount of water? And then obviously you have the directional joystick, right?
Yes. Yes. So
do you adjust the throttle and the water input while you're using it?
Yeah, there's also one more button at the remote control. This is the throttle. You can put it from 0 to 100. This is also on the remote control. The water itself depends. So our system is made depends on how much water you bring inside. The system is ready, is fully autark, and you just need to bring in the water. So when you're bringing 2,000 liters of water, then you use 2,000. And this is all, yeah. So you can take a truck with a pump and suck the water directly out of a lake or wherever, or the river. In our case, we are also offering roll-off containers with the water pump inside, with a foam mixing pump inside and a foam tank. And then you can suck the water, bring it to the box. Or you take the box directly and put it and take the water from a hydrant or something. You can also connect it directly there.
And what about the use? So you talked about one person working and the other 17 people all taking pictures, right? So and normally without your technology, these 17 people would all have to be working. So it seems like it's really a force multiplier in that it allows one person to do the job of many people. And as we're finding, less and less people entering the fire service, it's important that the technology be able to replace the efforts of many workers.
Yes, this is true. So normally, let's say in a real accident, the other 15 or 16 persons have also their job, which they are trying with the conventional firefighting hoses, etc., which they are working by side our system. So in this case, it was just when the system is running and you have the fire under control, then the other guys can do some other works.
Yeah.
Mm-hmm.
And do you envision this being able to supplement structure fire circumstances where a structure is just not safe to enter? Let's say, military situation, the building got struck with a missile, there's a fire in there. It's one building on a block of many. We don't want the fire to spread to the other buildings, but we also don't know whether the missile weakened the structure and it's not safe to go in there, can we, use the jet to inject water droplets and mist and fill the building, either just with water or water retardant combination, so that people don't have to go in there and still be able to put the fire out?
It's working from a safe distance, so nobody needs to go into this area. Yeah, or they can go into the area after a time, or several times when the system was running, and then you can put out the system or put it away, and then you check and say, okay, now we can enter. So this is possible, but this is a big advantage working from a safe distance when you have the range of about this 120 meter, and then you also have the range of the remote control of about another 150 meter. So you can, the person can work with the system, let's say 300 meters away from the fire.
I see. And then I guess your third level would be you could do an interface between the remote control and someone's iPhone, put all the controls on an app, and then they could just log into it and off they go.
So our system is connected with the internet. Okay. So this all depends if the customer if they're willing to do it. When they say no, we don't want to have the connection, they just take out the SIM card. But normally, when our system is running, we get the information. System now is running. System is starting, and we get let's say 4 messages. And the first one is system is starting. Second one is start ended. System is running now. And then system will be stopped, and then stop end. There you can control, is the system starting right, and is the system going down with the right parameters. So there we always know how long the system is running, and then we can check the data of the engine, etc. Is everything correct or not? And we also get the data when when you have the system or the fire truck always needs to be connected to the power supply when they are not used. So there we also get some information. Be careful, system is running out of power because it's not connected. So here we also help our customer that they don't forget our system or to put on the power when it's in the fire department or whatever. So this is connected. And here we can also use the data, and when the customer is willing to do, we can put the data on a dashboard so that the fire chief, for example, can use the data of the system to see, okay, the system is running now, the fuel is about this, or we need to talk about getting new fuel to the area or something. So this can be also used because the system is connected to with the internet too. Then you can work with the data.
They can use that data in real time.
Yes.
Right. And you see that data as well?
We see that data as well, yes. So we have the data, we have access to the data, and our jet engineer is then working with the data, and also our software person have the data, and then they are checking if everything is okay.
Fascinating, right?
Yeah, this is real fascinating. Yes. There's a lot of guys on our side, working behind the scenes and checking quality, etc., everything of the system. Yeah.
So it must be very satisfying when you see all of the work that your engineers have been doing, put to use out in the field.
Yes.
They're very proud of what they're seeing.
Yeah, for sure. Yeah. Mm-hmm.
Yeah, that's wonderful. Are there new unanticipated technologies or new things that you're working on, or new ways to apply the existing technology?
There are some new things. So we already produced together with the partner in Singapore with ST Engineering. We have let's say produced a new tracked vehicle, the Extreme V. In Singapore, they already had a former version, let's say the first version. Now we have the Extreme V 2.0, we call it. This is the new version which we have now introduced or produced for the German army, for the firefighters of the German army. There, at the moment, there is no Turbo Hydrojet as a payload at these systems. But here, we can also take our Turbo Hydrojet box and put it on the Extreme V, this tracked vehicle. It's a tracked vehicle where you can go nearly everywhere driving with the vehicle, and you can use the Extreme V as a payload for getting them into every area you need it. Or you put some other water tank or with water pump on the back as a payload, and have a water monitor in the front where you can steer inside of the cabin while driving through forest or wherever you want, and doing your fire work. And this is also a new thing which we done together with our partner ST Engineering in Singapore. And this is also, so this will be presented in a small version and with some videos the first time in the US in April at the FDIC in Indianapolis.
Oh, wonderful.
So there we are.
I'll come there and see.
Yes.
Yeah, that's very soon. Will you be there?
I'll be there. I will be there.
Oh, wonderful. I look forward to meeting you there.
I will be there. It's when is it? In 17th of April, so in 2 weeks.
Yes.
We are there.
Wow.
So first time presenting our technologies in the US. Yes.
Very exciting. You'll have some Kansas City barbecue. Huh?
Yes, great. Looking forward.
That's great. Are there like other new applications where customers are saying, could it be doing this? Could it be doing this? That you had not anticipated?
Mm-hmm. So we are also working now, or we also have a small turbo hydrojet system, which we are working now on. And this is already finished. Here we have now a new, like a robotic chassis where we put the small turbo hydrojet on it. Here we are working with the smaller engines. I guess the same which I see with behind you on your picture.
A little one, right? You can put this into a briefcase system, right?
Yes.
A little Halliburton case. Put your water in here, your diesel in here.
Yes. And here we are also having a smaller one, which is now, let's say the prototype was finished, and now we are doing the first demonstration also in about 2 or 3 weeks, presenting starting here in Europe with this system, put it on a remote control small chain chassis roboter where you can also drive and put the hoses directly there and track with the hoses everywhere, and also can drive into buildings.
With the little robots.
Yes, it's a little robot, can drive into the buildings. You can drive up the stairs or something. So this is now also new, which will be demonstrated this year the first time from our side.
How exciting!
The first, I think the first. I don't know if one of the videos I've sent you, the first one is already inside there, the prototype. I don't remember, but otherwise I can show you in the US.
Okay. I'm also curious about, so we talked about how much water we use, how much diesel we use. Now, what about input air? So the back of the jet engine is like a big vacuum cleaner, right? Pulling in a lot of air. Now, the volume of that air is multiplied when it gets heated. Mm-hmm. But you're still drawing a lot of air. And how do you make sure that what's coming in has enough oxygen in it if you're in a wildfire environment, or that you're not drawing debris into the engine? Yeah.
So you need to be sure that you have the kind of fresh air which is coming in. So to be honest, we have no experience now with the system directly into the wildfire and then sucking all this smoke inside. There we have, but here we have some theoretical calculations that we see. Okay, it's working until the air have. I don't have the real figures in mind now. I need to check this, but the system is working with. Until you have a percentage of fresh air.
I see. Mm-hmm. And so these jet engines, you're using them on the ground, where, we have a relatively dense, 21% oxygen or something, but these engines are designed to work, 30, 40,000 feet where there's much less oxygen.
Yes.
So being in a reduced, what we're anticipating is that being in a reduced oxygen environment on the surface of of the Earth
Yeah.
would be very similar to working at
Yeah,
40,000
this
feet.
is true.
And
Yeah.
so,
Hmm.
the engine should be okay if we don't have
Yes.
big chunks of ember going through it,
Yes. Yeah. Yeah. For sure.
tear up the blades, right?
Yeah.
That's
But here,
fascinating. Well, I'm
but
I'm
here.
very much looking forward to meeting you at FDIC,
Okay. Yeah.
and
Great. Yeah.
I'm
Also,
sure.
our jet engineer is also with us. So
Oh, wonderful!
he's more the technical guy, and yeah.
And you're with a business guy.
Yes. Yes. Mhm.
So, what's the business side like for you? We talked a lot about the technology. What do you find, demand, and how's the company growing, and how's all that?
Yeah. Is a good question because I was starting 2022 in February 2022, and in March 2022, this COVID situation came,
Yeah,
and so all the let's say all the planned projects and orders have broken away, and so we need to decide. And this was the time where we said, okay, we start with other systems and not only the Turbo Hydrojet system because these are projects which are running longer discussion with the customer and see if there is really a need and you need to present the system, etc. And this all broke away because you just did like we now online meetings and show the system, and nobody's buying this kind of technology during an online meeting. And so we decided to get new products in our company, and we started with, let's say, standard roll-off containers for regional fire departments. Then we started with firefighting trucks, but not with water inside, just logistic trucks, etc. And also with some special vehicles for firefighters. And this was then, let's say, the start also for getting after COVID to get the company grow, because then starting was 1.5 year was hard during this COVID period, but then you see all the hard work. You got the results for the hard work, and since then, let's say 2022 and now 2023, we nearly doubled the sales in 2023 for compared to the year 2022.
and so your business model is to sell the machine, not to
Yes,
sell the service, right?
we sell the machine and we are doing the service. So we are also
And the
doing the
service. So you have
service for
both in
every
your model.
machine. For every machine we are selling, we are also doing the service.
Oh, you're
So
talking about servicing the machine like maintenance contract,
yes,
but you're
yes.
not. But you're not providing the service of putting out fires.
No, no, no. We are just
I,
producing. We are producing the machines and selling the machines. Yes, no
I see.
service in cane. No, yeah, let's say in yeah, doing like yeah for renting, that somebody's renting the machine and the stuff for this. Until now, it's we haven't done it so far, but this is now also in yeah. Also, we are thinking about it because we learned from the US in kind of this all with the water and firefighting airplanes that this is the business model or business model in the US. And we also thought, why not? Why not bringing a turbo hydrojet system based on an Extreme V chain chassis or something, and bring it to the US, and then doing this as a service or service contractor, yeah,
Yeah, right.
where you can use the system. The only topic is always, but I guess this is, yeah, you also know how to bring the water to the system where you need it. This is always the biggest problem. But here we're also thinking when getting a turbo hydrojet in these, let's say, as a service provider, then we would also bring a unit with the water pump and a hose laying system, etc., as a separate unit. Then you have the
Right.
complete package which you can get or which you can rent or which you can use in case of fire.
And tell me about outside the case of fire. Do you have, customers or internal engineers who are thinking about uses for the technology that have nothing to do with fire?
With the turbo hydrojet technology, not so far. We with our other products for sure, with the Extreme V or something, because this is also an amphibious vehicle. This you can use for floods, for earthquakes or whatever. So here we are also working with the Ministry of Interior in Germany for the different other disasters which are happening, which are happening. And here we can also support with the special vehicles which we are producing.
Very, very interesting. Torsten, I so appreciate your time, and I'm just, really enjoy watching the progress that you're making with the company in such a short time. So I want to thank you so much for joining me on the show today.
Yeah, thank you for having me here. It was also my first time doing this also for the US, and it was a great experience. And I hope we stay in touch and we see us at the FDIC in Indianapolis.
Yeah, we'll see you there in April. That's wonderful.
Yes.
This is Torsten Gerwig. He's the CEO at DICOSI in Germany, using jet engines to blow out wildfires. Pretty similar technology, slightly different usage than what we're doing. But I would say, from a business standpoint, we're brothers now.
Yes, and, that's correct. Great.
Facing almost exactly the same challenges.
Yes.
So it was great to meet you. And I look forward to seeing you here. And thanks for joining us on the show. And thank you all for listening and watching The Fire Break. I'm Steve Wolf. We're sponsored by Team Wildfire. Check us out on the web at teamwildfire.com. And we'll see you next time. Take care.
Okay. Thank you. Take care.